Hello everyone. Now for this video, we are going to brief you how to do your planning in your questions. Now usually in a planning question, you'll be given a formula where you need to manipulate it to either obtain a linear or a proportional relationship. Okay, a linear or proportional relationship, and this will require you to apply the linear law in mathematics. Now that's because a linear relationship or a proportional relationship is easier to analyze because of a straight line in the graph. So because a straight line is much easier to analyze. Right, next, there's usually there'll be at least two quantities which you need to state out that has to remain constant. Now bear in mind that these two quantities need to be measurable. Now it's a common mistake by many students to just plug in anything that looks like it's not changed in the experiment and it's just throw in as a constant quantity. Well, that's not the case. You have to look through your practical, and you have to, from the practical, you need to understand the steps and then determine which quantities that needs to be remain constant. Now usually you look through the steps, there'll be some measurements that be asked to measure once, and somehow you don't measure it again. Now I'm not saying that those are constant, but do think through, they may be constant. This is kind of a hint. Right, next, you'll be asked to describe the experiment. Now, you can actually write that you need to set up the experiment according to one of the figures in the question. Please go ahead and do it. And then you have to write in such a way that by changing an independent variable, you have to measure the dependent variable. Write it in a way such as like this. And don't forget to, for each step, repeat the measurement of the dependent variable at least 3 times to get an average. And then repeat the whole process to get at least 6 sets of independent and dependent variable. At least 6 sets. And then from there, you have to decide, depending on the question, whether there will be any more calculations that's needed. And always remember to tabulate the data. Right, and tabulation of data requires you to write the first variable that's measured first, followed by the second, followed by the third, fourth, fifth, sixth, seventh. Right, whatever that is measured first or calculated first will have to come first. So that means your last column should be the last variable that is either measured or calculated. And then from the data, you can determine the graph to be plotted. And then you have to describe how the constants in the original question can be obtained from the graph. Next, you need to determine how the constants in the original questions can be obtained from the graph. That will require you to look at the manipulated equation, and from there, usually from either the gradient or the y-intercept or both, that you can describe how the constants can be obtained. Okay, now into the details. You need to manipulate the formula such that you obtain a mathematical relationship in a form of y equals mx plus c or y equals mx. And then, as mentioned earlier, you need to list down at least 2 quantities that need to remain constant. Now, again, I need to emphasize quantities that need to remain constant must be measurable. So one thing to note, when you change the independent variable, are there any quantities that may change if you are not being careful? So those most likely are the constants. And then during the description of the experiment, right, your first line you can start off with, set up the apparatus as shown in figure Well, over here I put 999, but you have to refer to the figure in the question paper. So there's no need to draw out the entire apparatus again, unless the apparatus is not shown. So you need to draw the whole setup. But in this case, I'm going to assume that the setup is there. So setup apparatus as shown in figure 999. And then you have to describe briefly how the independent variable x is measured. Okay, and then state record x. And then the next step, describe how the dependent variable y is measured. So every time you change x, you got to measure y. Instead, you need to record y and repeat the measurement at least 3 times to obtain the average value of y. So you need to repeat at least 3 times to obtain y. So that means to say, this step, the one I highlight in yellow, must be repeated 3 times. Okay, the one I highlighted in yellow must be repeated 3 times. And then following that, your part D, you can just say repeat step A to C. Now you see how I label the description A, B, C, D, E. Or you can label it 1, 2, 3, 4, 5, up to you. So for me, I label A, B, C, D, and then part D, I said repeat step A to C to obtain at least 5 sets of X and Y. So other than within step C itself, there's a repeat, right? This step and this step, this whole step. Okay, sorry, I made a mistake here. I'll amend it now. The mistake is this should be B. Repeat step B to C to obtain at least 5 sets of X and Y. You can state how X can be increased to give you the values. And then recall, you got to tabulate x, y, and list out other variables that are calculated from x and y. And finally, plot a graph of y against x. Now, this y against x doesn't mean one is dependent, the other one is independent. Notice I put a capital Y and a capital X. Right, it goes back to your original equation, which is y equals mx plus c. So I'm referring to this x and referring to this y, depending on how you manipulated the equation. And then you have to describe that you have to calculate the gradient and then describe from the gradient how it helps you determine the values that need to be calculated. And also from the graph, you can determine the y-intercept, and you have to describe how the y-intercept will help you determine the values that are needed. So the steps are pretty straightforward. Okay. As of now, this is just a brief overall view. Over the next few videos, I'm going to zoom in on a specific experiment to assist you better.